Greetings, my awesome mathematicians. Today I am going to go over the last transformation, and it is dilations. But first, here we go. You'll get this one. Yes, the bunny hill. All right, let me get set up here. And one more click here. There we go. All right, so dilations. Have you ever had to go to the eye doctor and they had to dilate your eyes? So they do that just so they can look in your inner eye, make sure everything's okay. And it is pretty crazy how big your pupils end up getting. So a dilation is where you either enlarge something or reduce something, and again, it stays that same shape. And so dilations correlate with similarity. We're going to talk about scale factor. We talked about that when we did our similar figures a couple weeks ago also. Scale factor, you can see, is going to be represented by the letter K. So if it ends up being greater than 1, that picture is going to get bigger. If the K is less than 1, it is going to be a reduction. All right, so let's take a look at a couple examples. Now, these aren't on a graph. We're just going to put this in the chart. I think we have 2 other examples that we'll actually graph and see what happens with the dilation. So you can see our numbers are pretty big here. We've got -5, 5, -5, 10. And so these are our pre-images, and so I'll just fill them in the chart. Now the dilation on this one, it says K equals 3. So what that means is we are going to take everything and times it by 3. So the sign stays the same. -5 times 3 is -15. 3 times 5 is 15. All right, so I'm just going through multiplying everything by 3. So this would be the image. Remember, this is the pre-image, and then we would have the image, and we would graph those points. And sometimes it would be, you can see numbers are pretty big here, but that would be the ordered pairs for the enlargement. Okay, let's take a look at a couple other examples, and then we'll actually graph those. Okay, so I'm going to put them in the chart first. So this is going to be a triangle. Here's our ordered pairs of the pre-image. And I'll go ahead and plot those. -2, 0, make sure you label it. This would be A. 2, 4, that would be B. Remember, this is our pre-image. 1, 2, 3, 4, -4, down 4, 1, 2, 3, 4. Okay, so let's see. Got straight edge here just to make it a little bit straighter. So this is our pre-image, and it looks like we're going to do a scale factor of 1/2. So this is an example of a reduction. So we are going to multiply everything by 1/2 or 0.5. You know, just in your mind, 1/2 is pretty easy to work with. So half of -2 is -1. Half of 2 is 1. Half of 4 is 2. Okay, make sure I got the right signs. It looks good. All right, so now I'm going to plot those points. -1, 0, and I'm going to use a different color here. I think it'll be easier to see then. -1, 0, so I'm going to label that A prime. 1, 2, B prime, and 2, -2, C prime. And so now you can see that we have reduced it. So the dimensions are in half, but you got to remember that the area shrunk by 1/4. Okay, so the dimensions are half, but the area, oops, if I can spell area right, is actually a fourth of the original. Okay, because actually 4 of these would end up fitting inside of that larger triangle. Okay, last example here. Another triangle. I think we have different dimensions here. Let's go F, -4, -2, -2, 4, and -2, -2. Okay, when I plot these again, I just use the capital letter. This is our pre-image. 1, 2, 3, 4, down 2, to the left 2, up 4. This one's F, this one's G, -2, -2. And that is H. Okay, so I'm going to go ahead. Looks like it's a right triangle. Let's see what we're going to do with this one. All right. So this one's kind of interesting. We have a scale factor of -1/2. So when we multiply, we want to make sure that we change everything to its opposite. All right, so now we're going to have half of -4 is -2, but a negative times a negative is a positive. We got to get our signs right. Okay, so anything times a negative, negative times negative is a positive. So I look okay there. Whoops, that's going to be +1. Got to be careful with signs. This is going to be -2. And then these will both be positive. All right, let's see what happens with this. Now, if you remember back from rotations, when we changed both the X and Y to their opposites, oh yeah, that was a 180-degree rotation. All right, so in plus, we're going to shrink it. So we're doing kind of 2 things here. Let's go ahead and plot it. 2, 1. Now that's going to be F prime. 1, -2. And that is G prime. And 1, 1. And that is H prime. Oh yeah, okay, so it ended up rotating. And we ended up shrinking it a 1/4 of the size. Okay, so again, just keep in mind, so dimensions are half, but the area is now a 1/4 the original size. Oh, let me slide that up real quick. Okay, so that concludes all 4 different transformations, with the last one being dilations. All right, so go ahead and get that glued in your notebook, and you'll be ready for some activities.